All right, day 3 notes using properties of isosceles and equilateral triangles. All right, example 1. Find x and length of each side if ABC is an isosceles triangle, AB equals BC. So what we've been doing all along, let's mark it. AB is equal to BC. And now we simply just do what we know. We know that this side equals that side. Now remember, we're dealing with sides now. And what happens is people start to do things like say that they add up to 180 or something crazy like that. Sides don't add up to 2 degrees. So just keep that in your mind. It's a common mistake. So now we're trying to solve for x. I like to keep my x's positive, so I'm going to subtract 2x. That's going to give me 2x minus 3 equals 5. Then I'm going to add 3 to both sides. 2x equals 8. Divide by 2. X equals 4. Let's see what the directions said. Find x and the length of each side. So if I plug 4 back in right here, 4 times 4 is 16, minus 3 is 13. Theoretically, this should be 13 also, but I'm going to check it. 4 times 2 is 8, plus 5 is 13, so that works. And if I plug in 4 right here, I get 6. So 6, 13, 13. Part B, find x and the length of each side if FGH is equilateral. That means all 3 sides are equal, which means you can pick any 2 of these and set them equal to each other. So 3x plus 10 equals 4x plus 1. Doesn't matter. All right? Now, again, I like to keep my x's positive, so I'm going to subtract 3x here. And that's going to give me 10 equals x plus 1. I'm going to subtract 1. That's going to give me 9. X is 9. So I'm going to plug it into all 3 spots. Here, here, and here. Theoretically, I should get the same answer. If I do it just to check. 9 times 3 is 27. Plus 10 is 37. 9 times 5 is 45. Minus 8 is 37. And 9 times 4 is 36. Plus 1 is 37. It works out. All right, example 2. For each triangle, find x and the measure of each side. I highly suggest you real quickly just draw a triangle. It says equilateral, so try to make it look equal. Not a big deal. F, G, H, doesn't matter how you label it. FG is x plus 5. GH is 3x minus 9. And FH is 2x minus 2. Now, being an equilateral triangle, it's not as important to map it out because any 3 of the sides are equal, but it's very important for isosceles, so you can make sure you remember which sides are equal. So FG x plus 5 equals either one. I'm going to do 2x minus 2. Again, keeping my x's positive, I'm going to move them to the right. So 5 equals x minus 2. Add 2. X equals 7. Now plugging in, 7 plus 5 is 12. 2 times 7 is 14, minus 2 is 12. 3 times 7 is 21, minus 9 is 12. We're going to skip this. All right. An isosceles triangle. Here's some vocabulary. The legs are the 2 congruent sides. The vertex angle is formed by the 2 legs. It's also the angle that is not equal to the other 2. So it's going to be the odd man out. Base angles are the angles opposite from the legs. So we've done this before. You know, these are opposite of each other. Rule, they're always equal to each other. So base angles are equal because they're opposite equal sides. We've talked about this before. And the base side is opposite the vertex angle. Okay, some concepts you need to know. And we talked about this already. If two angles in a triangle are congruent, the sides opposite them are congruent. So those are the legs. If two sides, the legs, are congruent, the opposite angles are congruent. So mark the congruent sides or angles. So I'm just going to draw there and mark them. I'm going to draw here and mark them. Again, here and mark them. All right, finding angles in isosceles triangles. Mark the base angles. Okay? Remember how many degrees all the angles are, 180. Subtract what you've already used and decide if you need to divide by 2. So, first off, I know this and this are the same, so I'm going to mark them equal. Now, again, I have $180 to spend at 3 stores. 180. I'm spending $52 at the first store. Okay? So what I'm going to do then is take 180 minus 52. And that's 128. Now, since these two are equal, I have to spend the same amount of money at both stores. So I'm just going to divide this by 2 and get 64 degrees. And here's the nice thing about that. I can take my calculator real quickly and add 64 plus 64 plus 52 and make sure that I get 180, which I do. Okay, this one's a little tricky. Here and here are the same. So I'm not going to subtract and divide by 2 because I have one of the base angles. So I can automatically write 63 degrees in here. So I'm going to do 63 plus 63 and find out how much I spent at these 2 stores. And then I'm going to do 180 minus 126 and get 54 degrees up here. Again, I can take these 3 numbers and add them up and make sure I get 180, which I do. All right, I already have these 2 marked. So I just take 180 minus 75. This one's, okay, we're going to get decimals, and that's all right. So if we take 180 minus 75, we get 105. We have to spend the same amount here and here. So I'm going to take 105 and divide it by 2. And I'm going to get 52.5, and that's okay, degrees for each. And if you're worried about it, add all 3 numbers up, and you will get 180. Last example. Angle LMN is an isosceles triangle. Whoops. Well, that just got all messed up. Okay. Now, it says angle L is the vertex angle. So I'm going to put that up here. And M and M, it doesn't matter which one I put where. LM is 3x minus 2. LN is 2x plus 1. These are the equal sides. And MN is 5x minus 2. Not important for the beginning, but will be for the end. I'm going to take the 2 sides, the 2 legs, and say 3x minus 2 equals 2x plus 1. I like to keep my x's positive, so I'm going to move them to the left. That gives me x minus 2 equals 1. Add 2 to both sides, and I get x equals 3. So that's my x. I'm going to plug 3 in. 3 times 3 is 9. Minus 2 is 7. 2 times 3 is 6, plus 1 is 7. That makes sense. They should be the same. And last but not least, the base, 5 times 3 is 15, minus 2 is 13. And that's it.